Okay, I'm Cindy Shelton, and I'm going to talk to you a little more about your midterm study guide. I'm going to talk to you about Chapter 3, the logic chapter. In logic, we try to judge statements true or false and find the validity of arguments, and we make truth tables to help us with that chore. So I'm going to start with 3.1, just some basic definitions. A simple statement is just conveying one thought that you can judge either true or false. Some connectives that add different thoughts together. Connectives would be and, or, if, and then. So on number 6 on your study guide, it says Jerry's wife loves soup. That's one idea. And a connective, she especially loves sandwiches. A second thought. So our question is this a compound statement? So yes, it is. It's two thoughts, so we consider that a compound statement. Simple, remember, is just one thought. All right, then it asks us to tell what type of statement that is, or what type of sentence that is. Simple, we've ruled that out. It's not simple. Conjunction is the kind of upside down V symbol. That means and. That's exactly what we have here, and that's our winner. Biconditional is when you have double arrows on the end. We call that biconditional, and both sides have to be true in that case. Disjunction is our or symbol. It's like a V. That's the or. Remember, this is and. And that's the one we said we've got here. Negation, whenever you do the opposite of a statement, say she does not love sandwiches, so negating that statement has this little squiggly line. And conditional has the one arrow. That's an if-then statement. All right, so we'll get to some of those others in just a minute. Okay, so that's number 6. So number 7 gives us a couple of simple statements. P says it is Tuesday. And remember, your Math Excel may regenerate slightly different problems, but they should be very similar. It is Tuesday. It's statement P, so it's going to help us with the symbolic language to label it with something to help us call that something. So statement P, it is Tuesday. Statement Q, the play is boring. It says write that statement in symbolic form. Write the following compound statement in symbolic form. So we're going to write if it is not Tuesday. So negating P, it is not Tuesday. So we said that's not P. And remember it said if it is not Tuesday, then, that's your if-then statement, which is the one arrow if-then statement, the conditional, then the play is not boring. The play is not boring. So that's a negation of statement Q. The play is boring, so this says the play is not boring. So we're negating statement Q. And that's our choice. Not P, then not Q. Okay, number 8. Number 8 says construct a truth table. So this moves us to 3.2, truth tables. A truth table for the following given statement. P or not Q. So like I said, every statement can be true or false. So statement P could be true. Statement Q could be true or false, I should say. So since we have two different statements, we have 4 possibilities, and that's what makes us make the truth table the way we construct it. We'll label P and Q, and both of these could be true. So statement P could be true, statement Q could be true. That's one possibility. Maybe just P is true and Q is false. So true, false. Maybe this one's false and this one's true, or they're both false. So those are just the 4 possibilities for those 2 statements. And that's what a truth table does. It lists all the possibilities. So if you only have 2 statements, you're going to have 4 possibilities. Every time you make a truth table with 2 statements, you have true, 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 false, and false, true, false, false. Okay, then we'll do what our statement says up here. It says to do the not of Q, the negation of Q. So that just means take column Q and do the opposite. Just not Q means the opposite of this. So F, that would be T, F, and T. And then do our compound statement. P, remember the V means or, not Q. Now when we do an or statement, that means either one of these could be true. P or Q, we're talking about column P or column not Q. So we're not even looking at this column anymore if you just want to block that out some way. We're just going to look at this and this column, and then or means as long as one of these, at least one is true, we'll label it validity as true. So true, false, that's true. True and true, that's true. False, false, that one is the only one that's not true, and false and true. Again, the or is as long as one of your statements is true, you label its truth value as true. And that would complete your truth table. Okay, number 9. Okay, we have a statement. I go to office hours, or, you know what that or means, that's the V, or ask questions. We have a comma, so it's like that's going to be in a parenthesis. I go to office hours or ask questions. Two ideas. Office hours, we're going to label that with a P. Ask questions with a Q. So the way we could represent this is P or Q. And that's in parentheses because it's partitions off as this idea, and then comma onto the next part. Okay, so then we say and is the upside down V. It looks like that. So that connective. And my professor does not remember me. Now, we could do this a couple of ways, but you have choices here, and we'll follow along with the choices that were given. So the way that it's given in the problem, it says, my professor remembers me, is statement R. My professor remembers me is statement R. So since it's a not remember me, it'll be the negation of R. So that is and then my professor does not remember me will be the negation of R. And so that's the choice you want to pick. Okay, now this is our big problem. So there's many parts to this. So after you do that, then it wants you to make a truth table for this whole idea, for all these statements. Since there's 3 simple statements given, I will need a truth table with a P, a Q, and an R, and all the possibilities, either all true, 2 are true, 1's true, all false, every possibility of those 3 statements. Okay, so here we go. Big truth table. Statements P, Q, and R. All possibilities of those. They could all be true. That, I guess, is the most obvious one. So true, 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 false, false, and on you go. But this is given in your problem, actually, so you will have this. True, false, true. I should do it in the same order it's on there. That doesn't really matter if you were making your own truth table, but since it's already printed on your Math Excel, I better do it that same way. False, true. But that's where these letters are coming from. It's just all the combos. All the possibilities of true and false for these 3 statements. So if you have 3 statements, you have 8 possibilities of all the combos. So the truth table starts with that. And then we're going to work with our compound statement and see which arguments are valid. So the first drop down says judge P or Q. So the first column, P or Q. Remember, if it's the V, that means or, so it can be as long as one of those statements is true, we'll label its validity as true. Truth value is true. So P and Q, that's these two columns, so try not to look at that column. P or Q, as long as one of these is true, I'm going to say true. So remember, as long as one is true, we say true. So that's not false, and that one's false. Both are F, F. So that's that column. The next column label is not R. Now again, these are easy. Just remember, not, the negation just means go to your column and do the opposite. So not R means do the opposite. Just keep focused on this line, or this column. Okay? And then the last column is the actual compound statement that we discovered in the part above, which we said would be P or Q, in parentheses, and not R. So the and statement, remember, was involved in this statement. So and means they have to both be true to get a true. And so not R is this column, P or Q is this column, so we're not looking over there, just looking at these two columns and doing the and part, the last part of the problem. So again, both have to be true. So that's false. There's our true. False. There's another true. False. True. False, true. Okay, so we have 1, 2, 3, 4 different possibilities for true. Oh, sorry. Actually, on the and, they had to both be true, didn't they? So that one was okay, that's okay, that's okay, but this one was false. Okay, then it says under which conditions is this statement true? So you look through your truth table and you decipher under what conditions, which ones are true, that it gives you that. So then you analyze that for part C. Okay, number 10, another truth table. For number 10, we're given a statement, not Q and P, biconditional, not P. Okay, so this actually moves us to section 3.3, by the way, the biconditional statements. So, again, all of these rules, there's just a bunch of rules, actually, that you just need to read, and you can click on your Math Excel homework assignment. Any homework assignment has a textbook link. Lets you go into the textbook, read the pages, and just page over till you feel like you've read all the rules. Copy those down until you get those straight, and it will help you do your homework. But the book will tell you this statement, this is called a biconditional, and it is only true when P and Q have the same truth value. All right, now this is a little different than our and or statements. The or, either one could be true and it was true, and then the and, they had to both be true to be true. Okay, that was our old rule. For this rule, the biconditional,